That brings back scarring memories.
Things that haven't changed since 2020. So.
Take a personal call.
That is not good. That's too important.
PTSD stands for personal.
I can edit it out, don't worry.
Oh my God.
All right. I think we are ready. Hello, everybody. Sorry for the delay. My name is Jakob, and we are going to be doing Hackschool Session 5 today, which is about servers. So just a few things to start. Number one, the ACM membership sign-in, courtesy of James, is Jakob, can you serve? Each word is capitalized. So if you're doing that, make sure to get that down now. It's also on the slides. Wait, let me see if I can move this thing. Go away. Oh, here we go. Okay, nice. How about here? Okay, so just as a quick recap, the last few weeks we've gone over HTML, CSS, and JavaScript. We got an introduction to React. Hey, don't worry, we're just starting. Then we went over events and state. And then last week, Shiyu went over navigation. And today we're going to be going over servers. And then next week, Einar is going to be going over generative AI. We're going to take a week off for Thanksgiving. And then week 9, we're going to be going over project deployment and having a showcase of any projects that you guys have made that you want to show. So we have a link to the slides there, and the link to the demos that we've been doing is right there. Right now, there's not a demo uploaded for this, but I will make sure to upload that in the next day or two. Okay, and then also, you guys have seen this slide before, but basically just don't feel obligated to take notes. The slides are going to be here, so you can always come back and reference them. And so just like make sure that you're getting everything that I'm saying, but don't feel obligated to write it all down necessarily. Okay, and then, I kind of went over this already, so I'm just going to skip the slide as well. So the game plan for today is we're going to basically give a quick introduction to servers. What are they and why do they need them? Why are they important to our web application? We're going to talk about the communication method of servers, which are network requests via HTTP. Then we're going to get into how we can create a server using Node. And we're going to talk about how to make our servers basically run as fast as possible, which we can do via asynchronous programming. So that's kind of a quick game plan. I'm so gonna get water. Sorry, I'm a little bit sick. Okay, so starting with servers. So a motivation for servers are, imagine that we're in a restaurant, right? You are going into a restaurant. You are the customer, you're the consumer of food, okay? What you see is like the exterior of the restaurant, as you're going in, it's decorated all nicely. The building looks cool. There's a sign, you walk in, there's like a nice carpet or whatever. There's a pretty setup. There's decorations all over the place, the cool vibes. There's waiters going around serving people and stuff. So you get a cool sense of like what's going on in the restaurant. You go and you sit down and you order food or drink. Point being, you order something and then you don't see that stuff being made. You just wait for a little bit and then eventually that stuff shows up at your table. So you do know that behind the scenes, there's a kitchen that's like preparing your food. And so again, behind the scenes is going to communicate with your table in the sense that there's a server that's going to bring the food from the kitchen to your face. So this serves as a good analogy for servers for a few reasons. And I'm wondering if you guys can think of like what the comparison would be. So again, we're imagining a restaurant. We are the web user. Does anyone know what the analogy would be for like the front of the restaurant where we're sitting and everything? Also, I need to Anyone? Yeah,
The website itself might be like the front.
exactly. The front end. Yeah. So that is the front end slash the web browser. That's like what we're accessing. Let's see, what do we have? Okay, we have skateboards, stickers, and squishies. What do you want?
How about a squishy?
All right. Do you like have anything in particular in mind that you want, or you don't care?
I don't care.
Okay. Okay. Cool. Great. Yeah. So what you see is the front end. You open up a website and you just get all this cool stuff flying at you and you see it all, right? What about what you order? What is like a good analogy for that? Okay, that's fine. That's going to be data, right? So you're going onto a website and then you are requesting some sort of information, and that information is going to be brought to you just like the kitchen is going to cook up your food and then bring it to your table, right? So that's what the food is. And then what about behind the scenes? If the front is, if the front of the website is the front end, then what would you consider the back of the restaurant? Back end. Yeah, exactly. Squishy, yeah. Oh no, I'm so sorry. Okay, I'm not going to try that again. So yeah, that is the back end or server of our application. And that's what we're going to be talking about today. And everything that we've been doing before is all like front end stuff. So behind the scenes, and yeah, this is just like another level of the analogy, just the behind the scenes communication to your table, which is the server bringing you food. That's the same as the server sending data to your web browser after you request it. So with that being said, can we come up with a proper definition for servers more than just they're like the kitchen in our restaurant? Can anyone give me something? Yeah.
The server is the computer that accepts the data from the user, processes it, and then like returns the necessary data and information back.
Yeah, that's magnificent. That's really close to the actual definition we have, which is that a server is a software application that is designed to store, process, and provide some sort of data, resources, or services to other computers and devices, which are called clients, and that's provided over a network. What do you want?
Anything's good.
Anything's good? Okay. Good. I guess they're not very aerodynamic, so. Yeah, so that's what a server is. Okay. So with that being said, with that definition in mind, we're going to quickly clarify some terminology. Firstly, you're going to see me using these interchangeable, and just people in general using these interchangeably all the time, which are client, front end, user interface. There's like a couple others. That is going to be the web browser. It's what you see. It's what you like load up. You go on Google, you type in twitter.com, and then you see the website. That is the front end of the website. On the others, and that's only like half, or like you can come up with whatever ratio you want, but there's a completely other side of every website, which is the server or backend, which is what services the clients over a network. So the front end doesn't have all of this data and like every single post that you see on Instagram and every single thing you see on the explore page, that all doesn't just exist like on your phone or on, Chrome or whatever. It exists because of this server that is doing all of this brute work behind the scenes, and it's running on its own. But the point of this is just, yeah, when I say server, I mean backend, like they're pretty interchangeable. And then there's also the database, which is like, do you guys know what a database is? Does that sound like relatively familiar? A database is basically just, it's a collection of data and it's accessed by a server. So all of the data is stored in your database, and your server is what has access to that database. So anytime that, and like, yeah, we can look at this image here that kind of shows it as well. The client is on the web browser, and that is the front end. And then it's going to make requests to the back end, which is the web server. And your web server is going to be able to perform any necessary logic, and it's also able to access the storage. So like when you go on Twitter and you go on your homepage, it's your browser is going to send a request to the server saying, can you find me all of the posts that have been made since I was last on the site. And then it goes to the database, it grabs all that stuff, brings it to the server, processes it, and then sends it back up to the front end where you can see it essentially. So with that being said, whenever I'm talking about client-side code, I'm talking about the code and the processes that run on our browser. Whenever I talk about server-side code, I'm talking about the code and processes that run on the back end on our web server. And if you're a full stack developer, that means that you have to have a mastery over all of those things. So you need to know the complete set of technologies that cover both the front and the back end. And like you'll see database lumped in back end as well. Depending on the size of the project that you're working on, it could be considered its own thing as well that's like beneath the back end. But for the most part, when you're working on like a smaller project, whenever you're doing back end stuff, you're also like accessing your database. So yeah. Okay. So wait, just right now, does anybody have any questions? Cool. So let's talk about an example, which is my UCLA. I don't know about you guys. I just enrolled for like some of my classes this morning, so this is what was on my mind. Does anyone know? Does anybody know? Once I click on computer science right here, this is like the class planner. I'm sure most of you are familiar with it. Once I click on computer science, can anyone tell me what's going to happen? Yeah. And so could you tell me again, what is that second search bar filled with? Like what? A list of classes. Yeah, exactly. So when I click on computer science, what do you want? Skateboard? Huh? Okay, sounds good. Sounds good. So when I click on the highlighted computer science field, my web browser is going to send a request to the UCLA server asking for all of the computer science classes being offered in the quarter in which I'm creating the plan. So I was in winter 2024 right now. So my web browser is going to send a request asking the server, can you give me all of the classes, all of the computer science classes that belong to winter 2024? Okay. And then, as you said, that second search bar is going to appear and there's going to be the list of the classes that I can select, right? So once I click on one of those classes, the server, oh, sorry, wait, okay, yeah, I basically just said that, but yeah, the server is going to process my request, obtain that list, process it in any way necessary, and then send it back to my browser as a response. And that's how I get this list right here in that second field. And then I can use that list. And then once I click on a class in that list, I'm going to be sending another request to my server, and it's going to find all of the sections of whatever class I choose and send it back to me. So that's going to happen right when I press go. Oh, no. Sorry. So once the server responds, the browser is going to update yet again with all of that information. And in this case, there's only one section being offered. But as we can see, when you're using your browser, there's a constant interaction between your browser and your server. And this is just like explicit times that we're literally clicking a button saying, I want this information. That doesn't include all of the times that your browser is just requesting some sort of information and then it's automatically loading on your page and you're not even thinking about it. So this communication between the client and the server is really fundamental for the process of web development because it allows you to add so much to your front end other than just static like information that's sitting there. So with that being said, we can define servers in the sense of we need them because of this client server architecture that we have. We need servers in order to properly store and serve the data and resources to our clients that we can't all just keep on the front end. And it allows our experience on our website to be dynamic, data-driven, and interactive. So I don't know, like when you guys first started coding your HTML websites, as you know, like everything was just sitting there and it's just a static web page. And then you're able to add in JavaScript, but that only allows like basic events and things to be occurring with what's already on the page. You know, there's not any like new data that's being introduced. There's not any like really computations that are happening. All of that is going to be necessary, like created because of the server. So yeah. So to talk about in more detail, the server and client communication, at a high level, the clients, as we said, are sending requests to the servers. Like, we don't know anything about these requests yet, besides the fact that they're requesting information. And then the server is going to process that request and provide a response to it, to us, or to the user, to the front end, right? It's kind of like a letter in the sense that every single message has to be like properly formatted. And I'm sure, as you can imagine, there needs to be systems in place in order to ensure that things are being properly communicated, the proper, the request gets processed properly, the response is properly. If there's a problem, we need to make sure to report it, and stuff like that. And with so many messages being sent, there needs to be a specific protocol in place for this to happen. And in order to talk more about that, we need to discuss HTTP, which is the protocol that is used for web communication. So before then, does anybody have any questions just about servers or anything so far? What's up?
So it was like a client to one server, could be like a client to one server and that server just to another one.
Yeah, absolutely. The server is kind of what is able to like spread out and communicate with anything else that is relevant to your application. So if there's like third-party stuff that you need to access, then your server is going to go and find that and then get it back and then give it back to the client. Yeah. Any other things? Cool. So now we're moving to the next portion, which is talking about network requests and HTTP. So HTTP stands for Hypertext Transfer Protocol. Like, you don't really need to understand why it's called that, but basically the requests are sent in the form of hypertext. Yeah. And as I previously said, it is the foundation of web communication. It is the primary protocol for transmitting information in and out of the through the internet, basically. And the other thing it does is it defines how data is structured, sent, and received. So if we look at this image right here, we can see our web client is over here. The HTTP protocol is in the middle and what allows us to interface between our web server and our web client. And as we see, our web server is what's going to be accessing server-side scripts that run and process data, and also is what accesses our database. But this protocol here is what allows us to do all of that stuff, right? So the method of communication that HTTP uses is HTTP requests, which are like the messages that are being sent back and forth, right? So what is in an HTTP request? Can anyone guess? Just to start. Just like a couple things. There's like 4 I have written down on the slide. Yeah. The person's IP address of the sender. Yeah. Yep, that's true. Anything else? Yeah. Yeah, keywords. Like, what do you mean by that? Yeah, no, there are keywords. Like, that's the correct answer, but do you have like an idea of like what some of them might be or what they do? If not, it's totally fine. Mm-hmm. Okay. What were you gonna say?
Like some sort of data from the user, like
Yeah.
what they want to specifically get information.
Yeah, totally. Okay, so to explicitly define, we have the header, which is the information such as the user's IP address that is actually requested. So that's going to contain like basically metadata about the request. We have the HTTP method, which is, I think, what you meant when you said keyword. The HTTP method is basically, what do we want the server to do? Like, what kind of request is this, So that's what the method is. And we'll get into like what these words exactly mean in a second. The URL, which is like, the URL that you like type into Google Chrome or whatever, that is itself an HTTP request. The URL, which is what specifies the web addresses of the requested resource, among other things. And then also, as you said, the body, which contains like the data that we want processed essentially. And just to get a little more specific about what's in the URL, it includes the scheme, which is HTTP, as we said, that's the protocol we're using, the host, which is the domain or IP address of the server. That's how we're able to reach the server, right? through the internet, the path, which is the location of the resource that we're trying to access on the server, and then also a query portion, which can contain like optional parameters. So yeah, here's an example HTTP request. Up here, we have the HTTP method, which is get, which we'll define in just a second. We have the URL, which includes the scheme, HTTP, the host of the server, and then the resource that we're requesting, which is a CSS file, which means like we're requesting the styling for our web page, essentially. This is the header, which includes a bunch of information that like we don't really need to get into. And then because this is a GET request, we don't need to have anything in our HTTP body. And yeah, you'll find out about that in just a second. But by the way, do you guys want stuff? You said you'll wait? Oh yeah, okay, perfect. Okay, you'll have to remember because I might not be able to remember at the end. So the first thing we're going to talk about is GET requests. These are like the most simple requests. They're the ones that are occurring the most often, and it is basically just asking your server for data. So you are just requesting some sort of like, what we were doing before on the MyUCLA page where we were requesting that that list of the classes being offered. That's a great example of a GET request. So it's used for retrieving web pages. Think about like when you type in a URL to go onto a website, that doesn't just like automatically appear. You're typing in the URL and then it's sending a request to the server saying, we need the landing page of that website. The server is finding it and then sending it back to you. And that's how you're even able to go on like the first page of a website. There's also, it's useful for obviously obtaining data, images, documents, any other like resources that you would need. So yeah, very fundamental and important for the use of websites. Another important thing to remember about GET requests is that there is no state change, meaning that when we make a GET request, we're not changing anything about the server. We're not changing any data on the server. It is literally just asking for something from your server, and then they're going to give it back to you. So we're not changing anything, which is different from the next method, which is a post request. A post request is sort of the opposite in the sense that you are taking some data that you have on your front end and sending it to the server and asking them to do something with it, which is probably storing it or like making some sort of computation on it, right? You're doing some sort of processing. This is useful for obviously like submitting forms. Like think about online, when you submit a form, that needs to go somewhere. So you're going to make a post request and send it to the server, and then your server is going to save the responses to that form in the database. Or like if you create an account for like a social media website or an account for anything, it has to save, like your address, your name, your username, your password, all that stuff. You have to bunch it all up, send it to the server. The server is going to process it in whatever way necessary, and then it's going to store that account information so that the next time you try to log in, the server can go and find it again. So yeah, it's useful for submitting forms, creating records, sending data that needs to be saved or processed in some way. And yeah. And so as we said before with the GET request, the reason that this is so much different is because there is a state change involved in this case, because it's changing the state of the server, it's modifying some data or adding some data. So that's very different than just asking it for a resource and then getting it. Hi, Anon. The other requests we have, like get and post are pretty much like the main ones that you need. We also have put, which is updating or replacing an existing resource. And the way that this is different is that if I make a post request with the same data over and over again, there's a possibility that it's going to get created like a bunch of times. So if I just have a piece of data and then I go post, then 5 entries of that data will be created. Whereas put is just updating that piece of data that already exists in the database. And then there's also delete, which like I'm sure you can assume is just deleting something. And there's more, but this is like pretty much what you need to know. So if we were to just summarize HTTP requests, when a browser is sending an HTTP request, it contains the method, which is get or post or something else, which is indicating what we want the server to do with our request and with what we're sending. We have the URL, which is specifying, among other things, the resource's location on the server and also like the server that we're sending it to. And then it contains any crucial message data in the header. And if we're sending a post request, it's going to include the data to be sent. So sorry, I don't know if I made that clear enough, but the body that was empty in the case of the GET request is going to be full in the case of a post request, because that's where the data that we're sending to the server is going to go. Yeah. So does anybody have any questions about that? Yeah.
So for like websites that have HTTPS, does that mean like the GET and POST requests are encrypted, or like what makes HTTPS different from
Yeah. Yeah, HTTPS is basically like an improvement upon HTTP. And yeah, one of the things is that it's encrypted, and I should know the other things, but I honestly forgot. I took 118 a bit ago. But you'll learn about it in 118. Yeah, sorry, does that answer your question though? Yeah. Encryption, yes, that's true. Cool. Any other questions? Cool. Okay. The next thing we're going to talk about is Node. So at this point right now, we know what a server is. We know how it communicates. We know, yeah, basically like what its purpose is. And we know that we are going to communicate in the server with our front end code using HTTP requests. But where does that leave us? What can we do now? So with that comes Node.js. And again, it's important to say now that before now, we've only used JavaScript in our web browser. So we've only used it as a part of front end code, where we are like taking, we're modifying something that's going on in the web page. We're saying like, when I press this button, I want the page to turn green, and that, or I want to increment this variable that's displayed on the page or something like that. We're using it for manipulating web page content. That's completely different than Node.js, which is allowing us to do server-side JavaScript. So it's allowing us to run and use a server in JavaScript. So to talk a little more about browser-based JavaScript versus Node.js, which is going to be backend JavaScript, the web browser JavaScript runs on the client side in the user's browser, and Node.js runs on the server side, which is outside of the browser. So, yeah, does anyone have any questions about that, or is that clear enough? Cool. So Node.js, because it's a backend JavaScript, it's going to be providing access to the file system of the server, the network, other resources such as like the database, and yeah. So it's very different than client-side JavaScript. But it's really nice that we are able to do our whole entire application in one language. So yeah, the benefits of Node are, as I just mentioned, one unified language. So we can do JavaScript for our client and for our server. Another thing is that it allows for a lot of efficiency because it is non-blocking and event-driven, which I'll talk a little bit more about later. And then the other thing is that it is scalable. It has a large ecosystem of packages that we can install, and it has a lot of community support because it's very widely used. And I have a couple other things on that image, but that's like the main stuff. So the key features of Node are, number one, package management, which is super duper nice. And that's what the next couple slides are going to be about. It is single-threaded, non-blocking model, which like you don't really need to understand what that means. But basically what I mean by single-threaded is that there is one process that is going through, and every single time something happens and we're trying to interact with the server, it's going to take that and give it to someone else for them to process it and fix it, and do whatever is necessary. So there's one like king process that is just going through and making sure that every single event that happens is going to get addressed. And yeah, also there is an event-driven architecture, which is kind of what I just mentioned. So to talk about package management, we have to talk about NPM, which is the Node Package Manager. It's a command line tool and is the package manager for Node.js. And just by the way, does anybody like know what package management is or like what packages are? So yeah, do you want to give it a shot?
It's sort of like a similar way to a library, and the way that it gives a bunch of tools that we can use that are developed by people.
Yeah, that's fantastic. I like that a lot. So yeah, packages are what allow us to integrate third-party code into our library, into our code. And a package manager is basically just managing all of that stuff for us so that we don't have to do it ourselves. So it's facilitating the use of all the software packages that we need. Basically, what that means is it makes it super easy for you to integrate third-party code into your application.
Okay, I found this on the web for basically what that means. It makes super easy for you to.
Sorry. Here are a few example NPM commands. I'll like properly define them later, but in it, that is like we're initializing something, install, we're installing something, update, we're updating something, search, we're finding something, uninstall, we're removing something. As you can see, like all of these seem super duper easy to use instead of, like going in on the internet and finding some link of something and then trying to like find a way to install all that. Like, no, they're literally just, you can go npm install with the name of the package and you're golden basically. One of the things was that in the React workshop, we have already used npm in order to install the React library, which is what allowed us to like make front end code using Node as well. So that's just one case where we've used Node already. So the reason that npm is so important is because it simplifies the integration of code into your application, and it allows you to really easily manage dependencies. So think about it, like as soon as you use someone else's code in your app, you are dependent on that person's code. If something goes wrong with it, your app is screwed. If something, if they make some sort of update, you need to make sure that you make that update too. If there's some method that you use a bunch of times in your code and then they just change the name of it, your stuff isn't going to work anymore. So you need to make sure to change it as well. So npm is going to automatically manage this for us, which is like just super duper nice. Yeah. So let's assume now that our project is using exterior code and we've installed it via npm. We need to know where that dependency information is located. And I'll explain why that's important in just a second. But basically, like, what libraries do we have? What version of those libraries are we using? Like, yeah, that's it. So the information about that is going to be found in your package.json file. So if you've ever like created a project using npm before and you were like, what the heck is this file for? That's what it's for. It's for all of the information about your project's dependencies. And the reason that that's super important is because it is crucial for sharing and reproducing your Node projects. So like if you are cloning, do you guys know what cloning is? Like git clone? Do you want to, yeah, go for it.
Or like cloning with your basic oftentimes just like how Git works and some of the information sometimes you don't. So cloning is just a way to like basically take existing code and just like do like make a copy.
Yeah. So someone's like repository is up on GitHub. You can git clone that and you get a copy of that repository not remotely, locally. And then you can mess with it, make changes, add to it, whatever, make new features. But anytime you're using JavaScript projects, you need to be able to get that dependency information onto your code as well, because otherwise you're just going to have their code and not the libraries that are used by that code. Oh, sorry. So it's crucial to be able for Node to be able to find that package.json file and then install all of those dependencies, and that way your project is going to be able to work. So with that being said, we can just go back to those commands quickly. Init, npm init is going to initialize a new Node project. Npm install is going to install the project dependencies from the package.json file. npm update is to update a package to the latest version. npm search is going to search through the wide like array of packages that exist in npm. And then uninstall is to uninstall a package. Does anybody have questions about that? Cool. Okay. So the next thing that we're going to talk about is express.js. This is a web application framework for Node.js, meaning that you are going to install it using npm. And it provides a high-level structure for building our web apps. So this is what we're going to be able to use to create our server. And it has features such as routing, middleware, templating. Basically, it just makes it really easy to create a server using JavaScript. So we have to talk about then routes and endpoints. A route is what defines how your server responds to a request that's made. And an endpoint is the specific path and URL that is associated with the route. So like when a user from a client makes a request, they're going to make a request to a specific endpoint, which is like a string. And that's going to entail like what kind of processing that they want to be done. It's kind of like a method. And then the route is what is defined like when that endpoint is called, the route is what's run. So it defines how the server is responding to the specific endpoint request that's going to be made. So we can see here the endpoint, if someone makes an endpoint to /dogs, then we need to have a specific implementation in our server that is going to respond to that request. So if they say get and /dogs, then we need our server to have some sort of route response that displays or that returns to the user a list of all the dogs. And yeah, there's a few other examples here as well. Yeah, does that like make sense for everybody? Cool. So routes are going to map HTTP methods and endpoints to the actual JavaScript functions that are performing the processing that is what our server is known for, essentially, right? So here we have a really basic express server that is being created. It's going to be const express equals require express, and express is the name of the package that we're requiring. And then we're creating a router using express.router. Like it's literally that easy. And then here are some sample routes that we have defined. So this is a get request, and this / is just means that that is the whole endpoint. It's just a /. So it's just the basic like first response request that's being made. And you could have something that says, like return hi or this worked or something like that, And another key thing that we need to see here is that the requests are going to have two things. We have rec and res. Rec is going to be used to access all of the information about the request. So the method, all of the data that is being sent is going to be in there. Yeah, where it came from, just basically all that stuff that we were talking about before about the HTTP requests and like the body, the header, all that is going to be in request. And then response is what you're going to use to facilitate the response to that request. Yeah. So we can talk a little bit more about the request and response cycle. So within a route handler, which is what we were just talking about, that's these things here. These are route handlers. Within a route handler, we are going to basically like the common practice of a route handler is going to access the request details. So it's important to see like, what is this request? What were they asking for? And we're going to use that using rec and res. That's the request and the response. We are going to manipulate any data that we need to manipulate. Okay, we're going to perform some sort of business logic, which like when people say business logic, they just mean like the name of the game for your app or for your business or for your company, like whatever it is, like it needs to be performed here. This is where like you get down to the nitty gritty and you perform like the, whatever it is that your app is known to do. And then you're going to interact with the databases and external services that you need to interact with based on what the request is. And finally, you need to send an appropriate response and importantly, set the response status code. So something I forgot to mention earlier about HTTP requests and responses is that every request has a response. And I don't know if you've seen like 404 error not found, that is like when you request a resource and then they don't find the error. So they send back 404 saying like, we don't know what you're talking about. And there's a bunch of these status codes that all are important and indicate different things. 200 is the status code that indicates a success. So if you get a 200, that means like, woo. And then 201, for example, is when something has been created. So if you make a post request and then you get a response and you send some data, like, a data for a newly created account, send that to the server. If the server sends back 201, that means that that entry was successfully created in your database. And yeah, there's like a bunch of response codes, and it's important to know what each one is. Let's see. So if we, in that previous example, we wanted to send something back using res, we could do res.status 200 and then .send, which is to send back a success. So this would send back to the client a 200 and just a simple message body saying success. Yeah. Okay. How much do we usually end at 7? Okay. I will leave this for the end if it has time, just because I also want to be able to talk about the last thing. Yeah, I was just going to basically create like a really simple Express server and then just show what happens when you like make a request and then get a response. But we'll see if we have time at the end. So the other thing I quickly wanted to talk about is the event-driven architecture at Node. This is what I talked about with like the one thread spinning around and getting events and then making sure that they're responded. So to have like just a super basic abstract understanding of this, this is our event loop, which is looping around, and every time it finds an event, it's sending it out for processing. So that means that we have an event queue, which is the queue of like events as they're occurring. They show up in this list, okay? So then the event loop is going to grab an event and then assign it to a thread, which you guys don't know about threads yet because I'm assuming most of you haven't taken CS33, but our computer having multiple threads is what allows us to parallelize, in the sense that we can do multiple things at once with different threads. So if you have like 4 active threads at once, then this one event loop is going to find 4 events, assign it to each different thread, and then all 4 of them can be processed at once. And so the reason that the single threaded event processing was important is because there's one, like, as I said, king thread that's getting each event, assigning it to a different thread to go out and do it, and then provide the response. So we're processing each event as it happens. Okay. So the last thing that I wanted to talk about is asynchronous programming. The motivation for asynchronous programming is that there are a lot of tasks that our computer does that it does really, really fast. Like our computer can do a bunch of things really fast, but there's also some things that take proportionally way, 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 way longer. So if our computer gets stuck doing any of those tasks, you're missing out on so much of the fast processing that it's able to do, right? And as I said, if your computer is able to do multiple things at once by taking advantage of having multiple threads, then it makes sense for us to be able to want to like take advantage of that fact, right? So some input and output bound operations, such as reading a file, making a network request, making a query to the database, or like doing anything that involves relying on an external service, could take like, you don't know how much time. It could take so much time. So if the main thread of our program is just sitting there waiting for it to be completed, then again, we're missing out on all of the other stuff that, there's just going to be a buildup of other stuff that the computer needs to address as soon as that event is over. So in order to, or like reading in a file, for example, like if there's a really, really fat file that your program needs to read in, you don't want to immediately assign like the main thread of your program to just sit there and read it in. Like we want to go and address other things. We don't need that file until later in the program, you know, we don't want to wait for it essentially. So how can we handle those tasks in a more efficient manner? And the answer to that is asynchronous programming. So what we can do using asynchronous programming is execute long tasks or any task, but specifically we should try to use it for long tasks outside of the main program flow. And this allows us to perform multiple operations at once. And it allows our program to move on from whatever current long task that it's waiting for and do other stuff while that long task completes in the background. So to talk about synchronous code versus asynchronous code, the synchronous code is stuff happening one after the other. So we have 5 instructions, do the first one, finish the first one, do the second one, finish the second one, do the third one, finish the third one. Asynchronously, the tasks are running concurrently. So we can go like start 1, go to 2, start 3, start 4, and then allow them to finish, you know, and then we can do 5 if 5 is depending on all 4 of those other tasks to complete. And we can see here that even a little bit of asynchronous additions can make a huge difference in the runtime of our program. So like, let's say we have 4 tasks here. One task takes 20 seconds, one takes 7, one takes 10, one takes 8. When we do all of those synchronously, one after the other, it's going to take 45 seconds. And if we do it asynchronously, we are only bound by the time of our longest task. So everything can be done in just the time of the first task, which is 20 seconds. Yeah, like, does everyone get like why that can be super useful and helpful? Okay, fantastic. I'm littering the recording. I feel horrible. So to talk about callback functions, they like, you don't really need to know too much about this, but basically just understand that they are functions that we pass into some sort of asynchronous instruction that we're running, and they are able to run once that task completes. So think about it this way, like we have our main program flow, we're going through that, and then we decide this task we're going to run asynchronously. So we're not going to wait for it to finish. We don't always necessarily know like when it's going to finish. We don't know where we're going to be when that finishes. So we can pass in a callback function into that function that's being run and say like, okay, I don't know when you're going to complete this, but as soon as you do this thing after it as well. And that allows us to like properly process the results of asynchronous code that is finishing. Yeah, so it's executed after the completion of an asynchronous task. That's all you really need to know about callback functions. They're like not super important right now. So how can we program asynchronously? Let me just, okay, how can we program asynchronously? So the first way we can do that is using promises. Promises are a structured way to handle asynchronous tasks, and they represent the future resolution of an asynchronous task. So like in your code, if you use a promise, you are agreeing to the fact that this result is not finished and it will be finished later, and we'll wait for that to be done until like to move on essentially. It has 3 different states. The first state is pending, meaning that the outcome is not known. The second state is fulfilled, which, so pending is how it starts, obviously, and then it can go 2 different ways. It can go into resolved or it can go into rejected. Resolved is just when whatever task we were waiting for in that promise, it completes properly, and then we have like the value, you know? So like if we were to create a promise around the running of some computation, like let's say it took like 2 hours to complete 5 times 5, then the promise would say that it's pending. And then as soon as that super long computation of 5 times 5 is completed, we're going to get 25 in that value of the variable that we set equal to the promise. Or if there's some sort of error, that's would be the case where it's rejected. And it failed to fulfill. So the other important thing that we can do, as I mentioned, it's sort of similar to the concept of callback functions, is promise chaining. We can chain promises together using two different keywords. We have dot then, which is going to use the fulfilled form of the promise. So you do like promise dot then, and then whatever you want to do with it. And then there's also dot catch, which is, I don't know if you guys have like try catch blocks in Python, but this is similar. Dot catch is going to catch an error. And yeah, so that would be when the promise gets rejected. And it allows us to create sequences of asynchronous operations, basically, which is super useful. So this is an example of a promise. I know this is like kind of dense, but if we look at it, we have a function here called fetch data that returns a new promise. And then all we're doing in this promise is setting a timeout for 1 second for 1,000 milliseconds, and then just creating data, which is just a message that says data successfully fetched. So when we call this function here, dot then is going to take the result of the fetch data function, which is this data message here. But before then, it's not going to do anything. So it's only going to run dot then once this timeout is finished and once the data is returned. And all we're doing here in this dot then, which is we're grabbing the result here of the promise, and then we're just logging the message. And then we also have a dot catch. We're catching the error that happens, and we're console.logging, or sorry, not console.logging, console.printing out the error. Yeah. The last thing I wanted to talk about is async await, which is also, does anybody have any questions right now? This is the last thing, so you can also ask questions after, but okay. So async await is another method of writing asynchronous code in a sequential and readable manner, essentially. So I'll talk about the specific keywords of async await, like I'll specifically define them on the next slide. But if we just look at this example here, we see we are naming a function async. So we're saying this function is asynchronous. And then we're doing this thing called await. And like, we don't exactly know what that is, right? We're awaiting some sort of promise. So let's go up here and look at what this promise is. The promise is returning a new promise that is, again, just simple example, setting a timeout and then committing a resolution. And it looks like this is going to be a 4-second wait. So what the await keyword is waiting for that promise to be resolved. So if you think of it kind of similar, if you're like, oh, that's similar to dot then, you're exactly right. Like they're very, very similar. So let result equals await promise is going to wait until that timeout is finished and the data is returned. And then the value of that variable, which will be promise resolved, is going to be in result. Yeah. So async is what allows us to declare a function as asynchronous. We're saying in this function, we are going to be running asynchronous code. And then await is the actual like async operation that is we're using that keyword to pause the asynchronous function's execution until whatever promise we're awaiting is resolved. Yeah, so here's an example of doing the exact same thing we did before in this promise, which was this right here. We're having that function fetch data that returns a new promise, and then we're calling that function and doing a dot then, which is going to take the result of the promise and just print out the message. We can do the exact same thing using async await. So here, this function fetch data, it's exactly the same. All that's different here is instead of just straight up calling fetch data and using dot then, we are naming an async function called fetch data async. We're trying to make a call here to fetch data and await the completion of the promise, and then console.log that promise's resolution and catch the error on the if there's an error. And so then we just have to call fetch data with async, because instead of just like, this is at the script level. So before we were just calling the function fetch data and using dot then. Now we're calling fetch data within another function that we've labeled as asynchronous. So we need to call that function here. And yeah, so as you can see, dot then and await are two ways of doing the same thing. So yeah, are there any questions about that? Cool. So just as like a quick recap of everything that we talked about, the big picture is servers. We are using them to provide our browser with data and perform any processing of that data and access any of the external services and databases and things that just contain all of like the details of our application. Our server and our client are going to communicate with each other via HTTP requests. And we can create a server in JavaScript using Node and Express. And we can manage the dependencies of our project using NPM and using Express, an additional package that we install using NPM. We can create routes that handle the requests that our client makes and respond to them. And again, in order to keep efficiency as a priority, especially with a server, which is going to do so much computation, so much going and finding data and stuff, we need to take advantage of asynchronous programming, which is going to allow us to run things in the background and perform other tasks in the meantime, which is very important for a server. And yeah, I think that's going to be it. So thank you guys very much. Does anybody have any questions about anything? Dope. If you answered a question, make sure to come up, and then we have pizza in the back. So yeah. Thanks, guys.